Convert from polar to rectangular form. We know what polar is. Polar turns these things into pretty little roses and hearts and stuff like that. Well, rectangular form is just the regular y equals blah, blah, blah. In order to do that, what we have to do is we have to use these three things. We have to say that x equals r cos theta. That's thing number one. We have to say that y equals r sine theta. It's supposed to be an n. That's thing number two. And we have to say that r squared equals x squared plus y squared. So in order for us to make this look like stuff with x's and y's, first thing we need to do is why don't we turn that r into r squared? Let's multiply it by r. If I multiply the left by r, I have to multiply the right by r. So the left is now r squared, and we'll change that in a little bit. Distributive property puts that r right after the 4. So 4, oh, look at that, r cos theta. Minus r times 4. Oh, r sine theta. Now we have enough information where we can start swapping things around. R squared is now x squared plus y squared. R cos theta is now x. R sine theta is now y. Now, maybe we could leave it like this, and maybe some teachers would be happy with this, but I'm not really happy with this. I'm not happy at all. What I want to do is I want to make it look a lot prettier. So I'm going to move everything to the left. I'm going to subtract 4x from both sides, minus 4x, and I'm going to add 4y to both sides, plus 4y. Let me get some colors out here. That gets me x squared minus 4x, leave some space, y squared plus 4y, leave some space, equals 0. Now, what I want to do is I want to make this look like something squared, x something squared. And I want to do the same thing with that. My goodness gracious. I want to do the same thing with that, but with a y squared. How do I do that? Well, difference of squares, of course. Take half of this number, square it, and add it to both sides. So half of 4 is negative 2. Square that is positive 4. So let's add 4 to both sides. Same thing over here. This is supposed to have a y attached to it, and I simply forgot. Same thing over here. Take half of 4, 2. Square that 4, and add 4 to both sides. What we have here is we have a perfect square trinomial that factors out to x minus 2 squared. Oh, what do we have here? A perfect square trinomial that factors out to y plus 2 squared. And what do we have over here? 8. So now it's in rectangular form, and it's a pretty version of rectangular form. That's what I like. That's what I want. And that's what I'm sticking with.